Hello. Hello, Mr. Eric, Mr. Ryan. Are you right?
Yes.
Okay, so where? Oh, look, this is coin, yeah. So look, they have head, tail. If I throw it, okay, I throw it. What's the probability of it
50.
Facing up? 50%, and another 50%.
But they both have electric sign on them.
Okay. Okay, but this is tail, this is head. Okay, let's say okay, 50% facing up, 50% facing down, right? Yeah. If I have two coins, 50% facing up each. If I throw the coin, each coin, once, what's the probability of I have two coins or both facing up?
25. 10.
50% facing up.
25%. Say 25%. 50 times 50%.
Yeah, we're done. So that's come on. Yeah, that will give us. Okay.
Why did half? Why is it half?
Half is 50%. The same thing. Yeah. 1/2. Right? Okay.
I got 25%.
Yeah, this is 25% exactly. Yeah. 1/4. Look, 1/4 is equals to what? If you times 25 over 100. Yeah, it's the same thing. Yeah. So it's the same thing, same portion, right? Alternatively, we can list all the possibility. Yeah. If we saying the facing up is 1, facing down is 0, right? So what's how many different outcomes if I throw these coins? Each coin once. So 2 coins. So look, it will be 1 1, both facing up. 1 2, 1 0, first facing up, second facing down. 0 1, first facing down, second facing up, and then 0 0, both facing down. Okay, so then we can pick those value. Yeah. Look, both facing up is 1/4, right? Both facing. Okay, what's the probability of both facing down?
A quarter.
It's the same. What's the probability of the 1 up, 1 down?
A quarter.
1 up, 1 down.
50%.
50%. Look, 2, right? 2/4, yeah? You pick 2, okay, exactly. Okay, so yeah, let's say that's the normal coin. How about if we have a coin that it's not normal? It's very strange. Like for example, the first coin 50% is regular, but second coin 20% facing up. If you throw the 10 times, only 2 times will facing up, will face up. Then what's the probability of if I throw each coin once, both coins facing up? 50% for the first coin, 20% for the second coin, 10%. Yeah, you times it together, right? Yeah, that exactly. Okay, so today's task is
50 times 20 is 1,000. Right.
but you have your percent, yeah.
So you divide by 0.
Divide 50% is equal to 50 divided by 100. Yeah, a percent. Look, this thing, yeah, this thing. What does it mean?
Modulus.
Oh, yeah, modular. But this thing is look
Percentage.
is percentage. You divide it by 100. Yeah? Look at 2 zeros. Yeah, 2 zeros. You move this here. Yeah. Okay. Divide by 100. Okay.
And then it will become a skateboard.
Okay.
It's a
Skateboard.
skateboard.
Okay. Okay. So let's say.
Let's show.
So we have. Come on. Can I put? We have a coin. We have a coin. So probabilities of facing up. Or let's say probability of facing up. Like a list of values of probability of each coin facing up. Like what did we say? 0.5, 0.2. Right? This is the probability of throwing this coin facing up. Yeah? And we are about to throw the coins, flip the coins exactly once per coin, right? So we want to find out what's the probability of having the K coins facing up. Yeah? K equals 2, and then you need to tell me is 1. It's 10%, yeah? It's 10%. 10% is 0.1, okay? Too noisy. Yeah, remember a few days ago we talked about the subset sum partitioning. So partitioning subset sum, remember? So what's partitioner? Yeah, we have a list of arrays 1, 5, 5, 11. Do you still remember this? We want to partition these into half, and both have an equal sum, right? First of all, we check the sum. If it's odd, the sum is odd, what happens? If this sum of the array is odd,
You can't can't
Yeah, because you can't separate it because all the numbers are positive. Yeah.
155 equals 11.
Yeah. Look, and then look at 11. We get the total sum is 22, and then the target sum we're looking for is 11. Yeah, and then we continue. We pick these numbers. Yeah, for each number we can pick or not pick, right? So if we pick, we subtract the sum this number from this, right? And then continue moving to the next one. Remember the DP function, right? Yeah, top down, bottom up, dynamic programming, yeah. Right? And we can skip. If we skip this number for this one, we still have 11 to pick, right? Yeah. So remember, DFS. We are picking the icon and then this is sum. We pick it, so we pick it with minus nums I, yeah. Or we don't pick it. Actually it's I plus 1. We go to the next coin and then we don't pick it and then sum will be remaining will be S, right? So for this problem, the coins, for each one, we can let it facing up, right? Or we can let it facing down, right? It's almost the same, right? Yeah. The only difference is that we have a probability, right? But for the coin, for each coin, we can have it facing up with that probability. And what's the probability of, for example, for this one, 20% facing up. What's the probability of facing down?
Facing down.
Come on, this is easy. 20% facing up, and what's the other half? 80% facing down. Yeah. So basically, one minus this number is the probability of facing down, because one, bless you, one is one is the 100%. 100% is everything. Yeah, it's total. It's the every outcome, right? And then I have 20% facing up, and the rest will be facing down, right? Because all these two events added up to 100%. Okay, yeah. So let's see. Okay. Let's see this. So this problem might seem a bit tricky at the beginning, but as I said, for each coin we have two choices. We can let it facing up with the probability pi, and if we let it facing down, it will be 1 minus pi, right? So let's say I have a function like DFS, and we want to pick from the ith coin, yeah? So if we look at the coins here, p equals 0.5, 0.2, blah, 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 okay? So we start from 0. Or we can start from the remaining, it's the same. Let's say we start from the beginning. We pick the first coin, right? With the some probability facing up, right? And then we go in from the right. So this is I, and then this is the coin, the number of coins facing up already, right? Yeah. So let's see if I is reaching the end, yeah, length probability, yeah. Then we need to do what? Return what? We want to return the number of the probability. Here will be a probability of 0 and 1. If k is 0, it means the probability is 1. Right? Return 1 if k is 0. Otherwise, 0. Okay? What does it mean? So it means that, okay, so this is the k. Remember the partition sum. It's the remaining sum. Yeah? If its sum is 0, right? We want to reduce it. So let's say at the beginning we want to call it 0 and then the k. Okay? So when it's k, ideally our target is to find the number of coins, coins which is k. We want to find out the k coins facing up, right? And then if we running out of coins, and then if there's no remaining coins to be facing up, then we return 1. Then it means that we find a solution, right? Otherwise, if we still have k is positive, then it means that it means what? It means what? It means we haven't enough. We haven't got enough coins facing up. Am I right? Yeah. Alright. Does it make sense? So now, if I pick it, if I this facing up, if I choose this facing up, I say choose equals DFS. I choose this one, and then I will have this I plus 1, right? If I choose it, then it will be k minus 1, right? And then this will be probability of facing up. So this is pi, right? Right? If I don't choose it, if I skip it, right? The opposite of choose is skip it. Is DFS. If I skip this coin, I still have to go to next coin, but I have this balance which is k because it's not subtracted. Yeah, skip it. And then the probability will be 1 minus pi. Am I right? Yeah, and then the return will be what? Return will be these two, right? Yeah, choose plus skip. Okay. Yeah, makes sense. Did it make sense?
Yeah.
Look, there are two. For this coin, I can let it facing up, and I can let it facing down. If I let it facing up, is this probability. If I let it facing down, okay. So maybe I rename it is at facing up, okay. Facing up, facing down, and here will be return facing up plus facing down. Okay, this probability. Yeah, yeah. The probability of this coin this ice coin facing up is this pi, right? Right? And then I need to choose the next coin. Yeah, pi plus 1, k minus 1. Look, because this is facing up, so I subtract 1. This is facing down. I keep it as it is. Am I right? Yeah. And does it make sense, Eric?
Kind of.
Kind of. Does it make sense? Yeah. So look, this is starting from I, and I can do it as the other way, which is from the end. So instead of from 0, I can say dfx from the length p minus 1 k, alright? Because at the beginning we want to find out if the possibility of having the k coins facing up, right? And then here I equal length p, this will be changed to if I smaller than 0, right? And this is the same. And this I need to change what? I plus 1, I need to change it to what? If I going from the right to the left.
I plus 1.
Change to what?
I minus.
I minus 1, yeah? Exactly, yeah? But look, let's say this one is I start from the first coin, right? I start from the first coin. I'm about to throw the first coin, right? And I want to have the probability of k coins facing up, right? So now, if it's facing up, the probability of facing up is pi, right? Pi here. The probability of the first coin facing down is 1 minus pi. When it's facing up, then the next coin I want to consider is I plus 1. But if it's already facing up, so because I want to look for the k coins, if it's already facing up, so what should we do with the k?
We should.
If it's this is quite similar to the partition sum. Remember? Yeah. Remember instead of k minus 1 in the partition sum, we subtract the number, right? Yeah. We not pick, right? This is correspond to the pick and not pick. This is facing up. Why is it minus 1? Anybody?
That's because that's the.
What's our target k?
Okay, is the.
We want to have k coins facing up, yeah? And now this coin facing up, so what should we do? We should look for k minus 1 coin facing up, right? Yeah, because this coin is already facing up, so we have k minus 1 to face up. But why this is still k?
That's because it's still the amount of.
Yeah, because it's facing down, right? So I still have k coins to face up, right? What's the probability of facing this coin facing down? 1 minus pi, right? Yeah, and then the result will be these two. Yeah, why this is plus, not multiply?
That's because you just count amount of.
These two events are independent, right? Independent. You add it there. But if these two coins, if these two events are associated, you multiply. Like the first coin 0.5, the second coin 0.5, and both coins having the facing up, then it's 10, right? Yeah. If 50% of the coins, if these two events are separate, right? Yeah, like there's 50% of the coin facing up, but and also there's another 50% this coin, single coin facing down. What's the probability of these two events? You pass it together. You not multiply because these two events are independent, right? Yeah. So for the probability, usually you have two kinds of operation. You multiply, yeah, or you add it. You add it if these two events are independent. You multiply if these two events are associated. What do we? It's like this coin, yeah. It's like the coin. If you want to have both coins, yeah. It's like do you remember the what naive Bayes, right? Naive Bayes, yeah. P, B, A, yeah. The probability of B given A occurs, okay? Given A occurs, yeah. The probability B given A occurs. The probability this is A, this is B. The probability of B given A occurs, right? You time this together, right? Yeah. Okay. What's the time complexity for this one? Remember? Yeah, this is quite similar to partitionism thingy. It's almost that. What's missing here?
Cash.
Well done, cash. Yeah. Because if we're not putting the cash,
It's exponential.
exponential, yeah, because these intermediate values will be you can treat we can look at this function because look, you have I belongs to what? Belongs to 0 to n, right? Yeah? Belongs to 0 to k. K is the integer, right? So the time, if this, how many states are there? So let's go. OKN, yeah? OKN. If we put a cache, there are how many possibilities for this function calls? I mean, DIK, KN, K times N, right? This is number, because look, I have N choice. Okay, so this is another probability. Now, I will be N choice, K will be K choice. How many different outcomes? How many different outcomes for this DFS function? This first number is I choice. Look, it's a table. It's a table. Yeah? You have this table. Yeah? You have this table. This is I. This is K. K will be start from 0, 1, 2 till K. Right? I will be start from 0, 1 till N. Right? So how many values are there?
N square.
No. This is N. This is K. Well, how many values are there?
N times K.
N times K, exactly, right? If we put a cache, yeah? Yeah? Please, don't touch it, yeah? It's shaking. Okay. So, yeah, if we put a cache, right? If we don't put a cache, what happens? Look, for example, I want to calculate this value, and I need to spend like 2 hours calculating this value, right? Okay, and then I'm done. I don't cache it. I store some value here. And then later here, you call this function again. And what happened? If there's no cache, what happened?
Just keep on doing the thing.
You will spend another 2 hours of working out this value before it's working out the value. Right? That's the magic of cache. We ask computer to remember for us. So only if we put a cache, what happened? Each value in the table is only calculated once. Alright? Yeah? I mean, does it make sense? Yeah? Because sometimes look, if I calculate this value, I might use other values in the table again, right? I might use these 2 values, 3 values, right? And again, I calculate this value. I need to work out this value. Look, if those values needs to be taking a lot of time to calculate it. If we spend like hours calculating this value, then exponential, right? That's the magic of putting cache. It makes sure that each value is calculated exactly once. Once we have the value, we remember here, let's say 1, let's 2. Okay? No, so I might spend 10 hours on these 2 to get the value 2. But next time I use it, I don't spend another 10 hours doing the same work again. Because I already calculated it. I put it in the notebook, right? Yeah? Does it make sense? It's like, okay, what's the sum of 1 plus 2 plus 3 plus till 100? Okay, 50, 50. What's the sum of 1 plus 2 plus 3 plus till 101? Yeah, come on, 101.
5,160.
Okay,
51.
how do you get this number?
Because I just add 101 to 50.
Exactly. That's dynamic programming. That's exactly dynamic programming, right? Because you already know this is the answer. So this bit is 5,050. You just need to add one more. Do you need to start from the beginning?
No.
No, that's dynamic programming, okay? Same thing.
It'll be 5151.
Same thing. But is this top down or bottom up? Top down. We put a cache. We ask computer to remember this for us. Proactive. If we want to store this value in this table, let's call what? What does it call? If we store the values in the table, what do we call it?
We call it
What's the opposite of top down?
bottom up.
Bottom up. We proactively store the values in this table, then we call it bottom up dynamic programming. But for this one, it's top down dynamic programming. Okay? Yeah? Make sense?
Yeah.
Look, okay, one other thing is that this is quite similar to picking the values. Yeah, picking the values. Look, picking the value instead of picking the value, you remember the partition, the subset sum. Yeah, instead of this probability, you have what? You have this sum k minus nums I, right? You just replace it with k nums I. Yeah, alright? Yeah, and all others are similar. Yeah, similar. Okay, instead of, because this is not we just return k equals 0, okay? It's not probability 1, 0. We just return true if k equals 0, otherwise false. Right? Remember the subset sum, right? Yeah? Make sense? For the subset sum, remember, yeah? For each number, we can pick or not pick. If we pick, we know minus 1. Instead, we minus what? Instead, we minus nums I, yeah? Yeah, this is the sum. Remember the 11 thing. Yeah, 1, 5, 5, 11. This is 22 sum. We want to look for the sum half, which is 11. K equals 11. Right? And then if we pick it, we subtract this number. If we not pick it, we still have the K sum, right? Yeah, and then we don't have this probability. Now, only difference is this. We have a probability here, and we have a minus 1 here, and return 1 if K equals 0, otherwise 0, okay? Make sense? Yeah? Any questions so far? Tomorrow we'll talk about bottom up, right? You see, the first day we talk about top down, the second day we talk about bottom up. Yeah? Make sense? Okay? That's it for today. Good job. Bye bye. Okay, one other thing, the time complexity. Time complexity.
N times K.
O(n) times K.
I'm watching TV.
What's the space complexity?
A1.
Look at this table. What's the time complexity? What's the space complexity?
O1. O(n) times K.
O(n) times K. Yeah, O(n) times K. We have this table, so it's O(n) times K.
TV.
So let's. Sorry, what do you mean?
I'm watching TV.
You're watching TV. Okay, so the time complexity, space complexity is both O and constant. Okay, that's it for today. Bye bye.
Bye.